Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So I'm going to start just by writing out the equation. And I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says to expand your answer fully. So we're just going to expand the brackets, 7m plus 70. So I'm going to start off just with a quick sketch, and we know that the bearing of B from A is 85 degrees. So we're going to have A here and B here, and let's just draw a line between them, and let's do both our north lines. And so we know that this angle here is 85 because it's the angle on the bearing of B from A, so it's 85 degrees. So now it says work out the bearing of A from B. So the first thing we can do is actually just draw a line going down here, and we know that this angle here will also be 85 degrees because of alternate angles. It's always best to write that down somewhere, so we can just put in brackets here alternate angles, and we know that this angle here is going to be 180 degrees because it's a straight line. And I'm not a fan of doing the reasons on the diagram, so maybe perhaps I should have labelled this an x and this a y and written x equals 85 and y equals 180 somewhere else. And so to work out what the bearing is, I just need to do 180 plus 85. So 180 plus 85 is going to be 265 degrees. This question seems a lot harder than it is. What I'm going to do is I'm going to start by rewriting the prime factors, but without the squared. So 2 times 3 times 3 times 5 times 5. I'm going to do the same with the other list as well. So 2 times 2 times 3 times 11. Now I'm going to put these into a Venn diagram. And so I'm just going to draw out a Venn diagram and get my two circles, because we're going to have the 450 and the 132. So 450 is on the left hand side and 132 is on the right hand side, and we're going to start just filling out the Venn diagram. So they both have a 2 in them and they both have a 3, but 450 has a 3, a 5 and a 5. And 132 has that 2 and the 11. Now to find the lowest common multiple, what you do is you just multiply all these numbers together, and that will give you the lowest common multiple. So what we're going to do is we're going to do 3 times 5 times 5, which are the numbers on the left, times 2 times 3, which are the numbers in the middle, times 2 times 11. And when we do that, we get 9,900. And that's it. So our answer is 9,900. So we're told that y is proportional directly to x. So what I'm going to do is just replace that proportionality sign for an equals, and I'm going to times the right hand side by k to be able to do that. Okay, we're told that x is 4 when y is 9.6, so we're going to put in 9.6 for y, I'm going to put in 4 for x, to be able to find out what k is. And k is a constant, which means it will always stay the same. So once we find it, we only need to find it once, and we found it forevermore. So that's going to be 2.4. And I'm just going to rewrite this equation here, but we know what k is now. We know it's 2.4. And I'm going to find out what y is when x is 5. So y equals 2.4 times 5, which will equal 12. So we know that y is 12. The important thing to realise in this question is that we know a female has been selected. So we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. So we're given 21 to 4 is the ratio. And we're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay. And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1, perfect, that's what we wanted. 4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. Factorising is the opposite of expanding. With expanding we're multiplying out a bracket, with factorising we're putting something in a bracket. So I'm going to start by just putting the bracket down. Now I need to ask myself, what number can I divide out of 3x squared and 5x? Well, there's not going to be a number I can divide out, but they both have at least an x. X squared obviously is x times x, and x is just on its own for the 5x. So we're going to divide out the x. So I need to ask myself, what times x is going to be 3x squared? Well, obviously 3x. And then we ask ourselves, what times x is 5x? Well, that's just going to be 5. And if you were to expand that set of brackets, you will get 3x squared plus 5x. So we know it's the correct one. And so our answer will be x brackets 3x plus 5. To draw a quadratic graph, we want to find as many values as we can. Because it's a curve, with a straight line graph, you only need 3 points. With a curve, you need as many as you can get. And now we're actually given a table here to fill out. And so I'm going to start off with a 0 here. And here we want to substitute in the x equals 0 into our equation. So we've got y equals x squared plus 11. So it's y equals 0 squared plus 11. 0 squared is just 0, plus 11 is going to be 11. We're going to do the same for 1. So y equals 1 squared plus 11. 1 squared is just 1. 1 plus 11 is 12. Same again for 2. 2 squared plus 11. 2 squared is 4. 4 plus 11 is 15. Now the minuses are a little bit more difficult, but not that much difficult, because when you square a negative, you actually get a positive. So minus 1 squared is just 1. 1 plus 11 is 12. And then minus 2 squared plus 11. Minus 2 squared is 4. 4 plus 11 is just 15. Now you can see here we get a nice little symmetry. And we're going to plot this onto our graph here. So 11 is going to be here. 12 is going to be here. So both of these are 12. And 15 is going to be here. Now when you join them up, what you want to do is avoid having a V. Okay, in the mark scheme specifically it says that the bottom needs to be nice and smooth, and avoid something called feathering where it looks like that. You just want one smooth line. Now the best way I find of doing it is turn the page sideways, which I can't do with mine, but you can turn your page sideways and just one smooth line, and we're going to do a nice smooth bottom there. And I just need to lift, try not to lift with yours, and that should be good enough for full marks. Let's just try it again, just have a bit more of a lift like that. That's also good, and I can do this all day. Like the ones that are bad are the ones with gaps, or the ones where they miss points. So if you had yours like this, where it just missed that point out, or something like that, that would not give you the mark. You just want one nice smooth, just slip there a little bit, nice smooth, and that probably wouldn't, because you can see that I've kind of hesitated there. So it just takes practice, and as I said, if you turn the page sideways, it's a lot easier to draw a C than a U. We can write the equation of any straight line as y equals mx plus c, m being the gradient and c being the y-intercept. Now the y-intercept is the easy one, because it's just where the line crosses the y-axis. In this case, it's going to cross it at 2. Now to find the gradient, we need to find two coordinates that we know, and preferably next to each other. So I'm going to pick the same coordinate, the y-intercept coordinate, and this coordinate here, we know what that is. And the definition of the gradient is for every one we go to the right, how far up we go. Well, here we actually go down, so we're technically going -3 up. So the gradient is going to be -3 because it's gone down 3. So our equation is m equals -3x plus 2. With these questions, it's normally easier to view these as two separate triangles. So we've got a small triangle here with 19 and 47. And what I'm going to do is I'm just going to move this out. And we've got a bigger triangle here. And we've got, well, we've got a bit of, we don't really know what any of the sides are just yet, but we can work them out. Okay, now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor, because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. So this question is a simultaneous equations question. And so we're going to have to write down some equations. So it says 2 apples and 3 pears cost £3.80. So 2 apples, I'm going to call it A for the price of an apple, plus 3 pears, so 3p, cost £3.80. Now I'm going to do this as 380 just because it's easier to work with integers rather than decimals. And it says 3 apples, so 3a, plus 8 pears costs £7.80. or 780 pence. Okay, so the first thing I do is try and get these numbers the same. So 3 and 8, they both go into 24, so I need to make them both 24. And what some people do is they just label this A and this B. And so what we're going to do here is we're going to multiply everything in equation A by 8, so that this becomes 24. So it's going to become 8A. And so we're going to times the 2A by 8, which will be 16A plus 24p, and 380 times 8 is 3040. And we're going to do the same with B, but this time we're going to times it by 3, so we're going to have 3b. And we're just going through everything here and we're timesing it by 3. So 9a plus 24p, which is good, that's what we wanted. and 780 times 3 is 2,340. So now we've got both of these the same coefficient. What we can do is we can eliminate going downwards. Now, if they are the same, the S in same is the S in subtract. If they were different signs, so if these weren't both positive, if one of them was negative, different, the D in different is the D in add. So here they are the same, so we are going to subtract, and we're going to subtract going downwards. So we're going to start off by doing, and I can just do a little line here to show what we're doing. So we're subtracting going downwards, and we're going to do 16a take away 9a, which will be 7a. 24p take away 24p, which is nothing, which is why we did that, is to eliminate them. And then 3040 take away 2340 will be 700. Then I can put my lines in, and all I need to do now is just divide both sides by 7, and I get A equals 100. So we know that apples cost 100, or £1. We need to work out what pears cost. So I just need to pick one of the equations. I'm just going to pick this top one here, and I'm going to write it out. Instead of A, we know that A is £1 or 100 pence. So plus 3p equals 380. So that's going to be 200 plus 3p is 380. And then again, I'm just going to draw my lines down. And we're going to subtract 200 from both sides. So it's going to be 3p equals 180. And then we're going to just divide by 3 both sides. And we've got p equals 60. So a pear costs 60. Now we can check this by using the other equation there. So 3 times 100 is 300, plus 8 lots of 60 is going to be, what's that, 480? So it's going to be 780. So we know that we've got it right. We're going to start by focusing on the A and B, which is 8 and 16. So in the middle is going to be 8 and 16. The next thing we're going to focus on is the fact that A is all the multiples of 4. Now 8 and 16 have both already been taken because they're in the middle. So the remaining multiples of 4 are the 4 there and the 12 there. So the next ones I'm going to focus on is the A or B. So A or B is in A, in B, or in the middle. So if we cross out the ones we've already used, so we've already used the 8 and 16 and the 4 and the 12, that leaves the 1 and the 9. We'll cross that out of our other list. And there's only 2 left in our everything list at the top. We've got the 3 and we've got the 11. So on the outside we have 3 and we have 11. So we've got a right angle triangle here, and we've given 2 lengths and an angle, or it involves 2 lengths and angles. That's going to be a trigonometry question. And to do trigonometry, we start off by labelling the sides. So we've got the hypotenuse opposite the right angle. The opposite is opposite the marked angle, and the adjacent is between the right angle and the marked angle. And we notice that the opposite doesn't have a number or letter next to it, so we get rid of that. Next step is to draw in our triangles. So they are going to be saw, ca, toa. We've crossed out the O, so we can cross out the toa and the saw, and that leaves us with the ca. So write out the formula, which is cos x equals A over h. Now the angle is what x represents in our formula. So that's going to be cos 42 equals what A is represented with an x, and the hypotenuse is 7.3. So next we get our solving lines in. And notice to get x on its own, what we're going to do is just times both sides by 7.3. And when we do that, 7.3 times cos 42. And be careful, when you type in cos 42, close the brackets, then times it by 7.3. A lot of calculators open brackets when you type in sine, cos or tan. And we get 5.4 4 blah 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 equals x. So round to 2 decimal places, it will be 5.42. To find the interquartile range from a cumulative frequency graph, you first of all see what the graph goes up to. Here you can see it goes up to 20. And what we do is we halve that, and that's the value we use to find the median. So we halve that again, and that's the value we find for the lower quartile, which will be 5. Then you add the 5 to the 10, so the number we use for the lower quartile to the number we use for the median, and we get 15. So those are the 2 points there that we will find our quartiles. So we draw a line across to find our lower quartile, a line across and down, and I think that is roughly, I think 22 roughly. We do the same again for our upper quartile, line across and down, and that's roughly, I mean these are going up in 4s, so maybe 37, because this line here would be 36, that would be 37. So to find the interquartile range, it is interquartile range, let's do the formula, is the upper quartile take away the lower quartile. Upper quartile is 37, lower quartile we said is 22, and so 37 take away 22 is going to be 15. Now if you've got slightly different values, that's absolutely fine. The exam will always give a bit of leeway, especially when reading off graphs. So here we're going to solve a quadratic using a calculator, using the quadratic formula. And the reason we know that is it asks us to do it to 2 decimal places, so chances are it's not going to factorise. So we're going to find out what a, b and c are. And a is the number before the x squared, the coefficient of the x squared, which would be 5. B is the coefficient of the x, which would be minus 6. And then c is the number left over at the end. So we're going to write the quadratic formula, but with our values in it. So we have minus b. Now I always put the values I substitute in brackets, and the reason is that if they're negative, you can make mistakes, especially here. When it's b squared, if you don't put it into brackets, it won't give you the right answer because it will square the 6 and then put a minus before it. Minus 4 times a times c. And if you always put them in brackets, you don't even have to think about it. It'll always be right. And then over 2 times a. Okay, we're going to put that into our calculator with a plus there first. And it gives us 2.320 blah blah blah. And we're going to do the same thing again, but we're going to use our calculator to go back to the plus there, and we're going to change it to a minus, and then we're going to press equals. And that gives us minus 1.120 blah blah blah. So to 2 decimal places, it's going to be 2.32 and minus 1.12. We're going to start by working out what outcomes will give us 2 different types of drink. So we could have OA or AO. We could have AW or WA. And we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO. Same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, well, the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27. And then 12 over 26. And so that would be 108 over 702. And then orange juice, then water will be 6 over 27 and 12 over 26. And that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together. And when you add them together, you get 234 over 702. Now, I said we would deal with the reverse situations now. We're going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator. So 468 over 702. That cancels down to 2/3. So there is a 2/3 chance that the drinks will be different. Okay, so we're going to start by creating a cuboid, just so we can kind of visualize what's going on a little bit easier. And so the lengths on the cuboid, it says, are 14, 10, and 8. Doesn't matter which way around. Now the longest part of the cuboid will be the diagonal across it. So if I just show a diagonal there, and it doesn't really matter which one we pick. Ooh. I could pick this one here, go diagonal like that. They're all the same length, all the diagonals across. So the rod will be, if it's the maximum length of the rod, it will be along this diagonal. So we can first of all have to work out what this length here will be, and then we can use the fact that this is 8 here and work out what the length of the diagonal is. So I'm going to call this X, and I'm going to call the diagonal Y, just so we've got something to refer to in our working out. And it might be helpful that this side here is 10. So we've got a right angle triangle, because this is right angled here, and we're looking for the value of X. So we know that we're going to be using Pythagoras, because we've got 2 lengths and we're looking for a 3rd length. So it's a squared plus b squared equals c squared. So it would be 10 squared plus 14 squared equals c squared. And it's actually not c, we've called it x, so why don't I stay consistent, equals x squared. So I'm going to do 100 plus 196, which would be 296 equals x squared. And get our lines in. Should be quite easy because we just need to square root both sides. So I'm just going to square root that, and we get an answer of 17.20 blah blah blah. Now I'm going to keep that value in the calculator itself, because I'm going to use that to find out what y is, our diagonal. So the next thing we're going to do is, we know what this is, and this creates a right angle triangle here, and so we're just going to do exactly the same thing again. A squared plus b squared equals c squared. Our a is 8, so 8 squared plus, and then we've got 17.20 blah 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 squared equals, and then we're looking for y, so y squared. Now if I square the value that's in my calculator from before, the 17.20, and if I just click square it, it will put it back to 296, because I've square rooted it and then I'm just squaring it again. So it would be 64 plus 296 equals y squared. So I'm just going to add them together, which will be 360. And And again, I'm just going to put my solving lines in. Not too difficult to solve this. Make it a bit nicer, because I'm just going to square root both sides. So I'm going to square root this, and it gives me the answer of 18.9736 blah 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 equals y. Now it says it wants the answer to 2 decimal places, so it would be 18.97 to 2 decimal places. Now a different way we could have done this is we could have worked out y straight away by working out the, like, I don't know what to call them. I'm gonna label them A, B, and C. So A, B, and C. And what you can do is you can do the y squared equals A squared plus B squared plus C squared. It's basically the width squared plus the length squared plus the height squared. And so we would have had 14 squared plus 10 squared plus 8 squared. And when you've done that, you would have got 360. And this would be y squared equals. And then when I put the solving lines in, I would have done the same thing, square rooted both sides, and you obviously would get the 18.973 blah 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 again, and then you would have written down the answer. So there's 2 different ways of doing that. Obviously this way is a lot quicker, but you have to just remember that if you've got 3 lengths on the cuboid and you'll ask for the diagonal, then this formula here can be a much quicker way of finding the answer. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.